Hi, I'm Bakka Venkat Subbareddy. My registration number 19BEC0523, and this is the task 3. So let's see the first question. So we have to write a 8051 assembly level program using the timer 1, mode 1 to generate a 1 kilohertz square wave frequency on one of the pins of a P1. Then examine the frequency using the oscilloscope in the KL simulator. So let's see the aim. So we have to write, our aim is to write 8051 ELP using timer 1 to generate a 1 kilohertz square wave frequency on one of the pins of P1. So tools required is KL software, and this is the algorithm. So this is the flow chart, and this is the program, and this is the tabulation. Excel sheet, I have given the link here for the Excel sheet. This is the output, and I've done some this is the manual calculation of this question, and as you can see here, I've done the manual calculation here, and this is the graph work that I've done. So, and the snapshot before the execution and after the execution. As you can see, I have highlighted the output, and so the total memory required to store the program is 22 bytes, and addressing modes used as immediate 3, and data types of instruction used are data transfer 2, branching 3, bit manipulation 6, and no flag is affected. So the output wave was found to be 961001 hex, which is similar to 1 kilohertz. So this is the final result of the first question, and now let's see the second question. So our second question is to write an 8051 assembly level program using the timer 0 and mode 1 to generate a 500 hex square wave frequency on one of the pins of P1. Then examine the frequency using an oscilloscope in the KL simulator. Repeat 1 and 2 for the multiplication of your registration number digits excluding 0 with the class series number micro X frequency. So this is the example, sample of this question. So here our aim is to find the 8051 ALP program using timer 0 to generate a 500 hex square wave frequency on one of the pins of P1, and tools required is KL software, and this is the algorithm, and this is the flow chart, and this is the program, and this is the tabulation. In Excel sheet I have given the link in the PDF, and this is the output, and this is the manual calculation and the graph work done for the second question, and the snapshots before execution and after the execution. I've highlighted the output on the left corner, as you can see here, and the storage required to store in the memory is 22 bytes, and the addressing modes used is intermediate 3. Types of instructions used is data transfer 2, branching 3, bit manipulation 6. So no flag is affected, and this is the final result for the second question. Let's move on to the third question. So we have to write an assemble 8051 assembly level program to toggle all the bits of the P0, P1 and P2 continuously by sending 55 Hz and AH to these ports, but a time delay between the on and off states. So then using the simulator single step through the program and examine the ports. Do not single step through the time delay call. So let's see the aim. So our aim is to assemble and toggle all the bits of P0, P01 and P02 to put a time delay between the on and off states using KL software, and to verify the result manually. So tools required are firstly CAL software, and this is the algorithm, and this is the flowchart, and this is the program, and this is the tabulation, and the link for the Excel sheet, and this is the manual calculation that I've done, and screenshots before the execution and after the execution. As you can see, I have highlighted the output in the left corner. So the memory required to store the program is 30 bytes, and addressing modes used is immediate 3, direct 4, implicit 2. Types of instructions used are data transfer 7, branching 7, logical 1. No flag is affected. Output is toggling was observed. So this is the final output for the third question. So moving on to the fourth question, our aim is to assemble and toggle all the bits of P0, P1 and P2, and to put them delay between the on and off states using CAL software, and to verify the result manually. So tools required is CAL software. This is the algorithm, and this is the flowchart. So this is the program and tabulation, link for the Excel sheet, and screenshots before the execution and after the execution. And this is the snapshots after the execution. As you can see, I've highlighted the output in the left corner. This is the output, and port 2 OFFX to OXFF to OX50. I've highlighted the output here as well, and in port 3, so this is the output, and the storage required to store the program in the memory is 8 bytes, and addressing modes used immediate 1, register 6. Type of instruction used is data transfer 7, branching 1, logical 2. No flag is affected, and this is the final output or final result for this fourth question. And let's move on to the fifth question. Our aim is to write a 8051 assembly level program to get a byte of hex data from P1, convert it into the decimal, and then to ASCII. So tools required is CAL software, and the algorithm this is the algorithm, and this is the flowchart, this is the program, this is manual calculation, tabulation, link for the Excel sheet, and snapshots before the execution and snapshots after the execution. I've highlighted the output here in the left corner, as you can see here. And memory required to store the program is 18 bytes, and the addressing modes used to immediate 1, register 6. And types of instruction used is data transfer 7, branching 1, logical 2. No flag is affected, and the final result is this. Thank you.